Morning, everyone. Welcome this morning to this webinar we're going to have in the next few minutes. Simulation 101. My name is Siddhan Jain, and I'm a manufacturing technical specialist with Symmetry Ireland. I'm glad to have you guys join me today. We're going to go over a few bits just around our simulation offerings to see what people are currently using and what are the benefits of using simulation within your workflows. So, just a quick introduction of myself. I'm an experienced product design and finite element analysis engineer. I've been certified by Autodesk as an instructor for Inventor and also by Altair for SimSolid. I am primarily focused on manufacturing softwares, uh, primarily design based, which is Autodesk Inventor, Fusion 360, and also I have keen interest and certification in the simulation world for Autodesk, such as Inventor and Astron. I have an interest in motorsport and football as well, with a passion for technology and engineering. So I do enjoy a lot of engineering documentaries as well. So it's um, it's nice to be joined by a team of other engineers who share similar interests. So let's get started today with what we want to go over. So initially, we're just going to talk around why or what is the need for simulation. What are the front simulation solutions that are available to you guys, and how you can access any trials if you wanted to inculcate simulation within your workflows. At the end, we're going to have a quick question and answer session as well. So if you have any questions, you can put them into chat and we'll crack on with the webinar then. So, why use simulation within your design workflows? Here is a little simple image of where simulation can come in within your design workflows. Essentially, for any product you end up designing, there's a concept stage, design and engineering stage, testing, manufacturing, and then it goes out into the field. So concurrently, if you were to inculcate simulation workflows within your design and engineering environments, what it can help you with is to validate designs earlier. It'll help you cut costs due to failures in service. Additionally, what it also does is it's going to help you optimize material costs. So essentially, your product can be lighter, can be faster to market as well, and you can have full faith within your designs as well. So you don't have to worry about the questions that engineers face on a day-to-day basis. Will my design fail? What happens if the product is dropped from a certain height? How light could you possibly make it just to save on material costs and obviously improve performance as well? And additionally, how strong does it need to be? So depending on what materials you use as well, there is going to be a strength requirement, a weight requirement as well. So to make sure that you have that delicate balance together, you would need to go through a couple of what if questions within your workflows. So around that, what we have seen with our own customers as well, and how traditionally we've seen industries working, is they tend to do a lot of testing or physical prototyping, as you can see within this video that's on your screens. Basically, right, the idea with simulation is to reduce your design and development times, essentially save you the hassle of having to physically test your product, ensure that there's quality within your designs, quality within the products you manufacture, avoiding in-field failures, essentially, right? So you don't want your products failing while they're being used. Obviously, nobody likes a bad customer experience. So trying to ensure that your products are up to the mark or up to a certain rating that you're trying to achieve it for, you want to ensure that what you're going with is the correct design. With simulation, right, what tends to happen is you also end up innovating a lot. Just from the example on your screens there, you can see the difference between the two Dell laptops that are being displayed. The one on the left is old, looks heavy as well, and of course, it's not the easiest to carry around. While the other one that you're seeing on the right basically shows optimizing design, making the same or getting the same performance out of your laptops by innovating designs and making them thinner and lighter for easier maneuverability and being able to carry them around. So essentially, you'll have increased confidence in your designs, so much so that you don't have to go through a entirely physical prototyping dependent testing phase, where you can greenlight your design, put it through prototyping, test it once, and be assured that your design actually works right. So there's a couple of simulation solutions that we are currently offering. For our Autodesk customers who have the product design and manufacturing collection, there are a couple of stress or a couple of analysis tools that are available within the collection itself. And we recently partnered up with a company called Altair. Now, Altair are a organization that is primarily focused on trying to simulate anything that you design. It doesn't matter what industry you're in, anything that you do, anything that requires a bit of simulation, I'm sure Altair have a product to match. Now, before I go ahead and show you the next few slides, I just want to quickly talk about what Autodesk solutions are currently on offer. Now, I'm sure that majority of you are CAD users, so Inventor would be primarily one of those. Now, within Inventor, what you have is a simple solution for linear analysis and modal analysis. So you have a section within your Inventor environments called Inventor Stress, which allows you to carry out these particular analysis types. So you can test out two element types, which are solids and shells. So if you have a very basic requirement for Inventor Stress, it does kind of fulfill the need. So for a very basic stress analysis, Inventor Stress does the job. Now, what we also have available is the frame analysis option. So those of you who work a lot with frame members, even within the Inventor application itself, you have the design accelerators for frame generator from sorry, for frame generation, right? What you can actually do is you can test out how your frames are going to behave in the real world environment by applying loads and looking at what the reaction forces are, what the displacement is going to be, and whether or not your frame members can be rated for the analysis you want to do. Then, which is the next level from your basic simulation elements within Inventor, is a product called Inventor Nastran. Now, this product is included within the product design and manufacturing collection. So, for those of you who've got access to the wider range of Inventor products, which is Inventor Nastran, inside the PDMC collection, it's exclusively available inside the PDMC collection, essentially. Is the Inventor Nastran software, which is basically an installer on top of your current Inventor application. So it allows you to carry out a lot of kind of different analysis. It's basically a simulation software using the Nastran solver itself. So you have buckling analysis, fatigue analysis, nonlinear, and a couple of more analysis such as dynamics and thermal analysis as well. So there are obviously various options available to you. Depending on what your simulation needs are, we can obviously advise on what might be the best tool for you guys to use or inculcate within your workflows. Now, of course, the question always is, where do you start with simulation? My answer always to that question is you always start at the beginning. So from the basics, if you look at Inventor Stress, build it up to going up into Inventor Nastran. That is where you can be assured that your designs and your workflows can go hand in hand. Um, I suppose the next thing then that I want to talk to you about is we do have kind of training courses that we run around the simulation environment. So we do go through stress analysis, frame analysis, and Inventor Nastran analysis as well. So again, you can talk to us about that at a later stage, or I will be showing my contact details at the end of this webinar, and you can send me an email or feel free to actually send me an email if you have any questions around simulation at all. So the upfront simulation solutions that we offer, why is simulation necessary, or why are we pushing simulation for our customers? Now, there is a kind of common theme that goes around basic FEA softwares. Now, I'm not just talking about Inventor and Nastran, but our competitors even have similar kind of solutions available. But there is a common factor within all of them that can cause, or that tends to be, a pain point for many research and design engineers. For example, one of them problems are meshing. Now, depending on your familiarity with the simulation software or any familiarity with how simulation works, you all know that, or you're all aware that meshing essentially is a critical part of the simulation workflow. So essentially, the workflow generally is you design the part, you put it through the simulation software, but before you can run the analysis, you need to kind of set it up for the analysis stage itself. So that setup can involve meshing, which essentially is to calculate localized stresses or try to help you find out where your maximum stresses are going to be, or where you probably might end up finding issues within your design. So that begs the second question, right? Now, generally, all of us are designing assemblies as such. So, how do you push through assemblies into something, into a traditional FEA software? Now, for those who are actually experienced, you probably are aware of the fact that it's not the easiest thing to do. It involves a lot of geometry simplification, such as you need to get rid of welds, you need to get rid of bolted connections, you need to make sure that any smaller kind of part gaps or overlaps aren't there. If you have products that are extremely complex in geometry, that can lead to issues. You have issues with thick parts or thin parts, and smaller geometric features such as fillets and chamfers do end up causing issues in traditional FEA software. So they tend to cause stress singularities, and that is something that no engineer likes seeing on their screen. Now, why are we bringing Altair SimSolid to you guys? Now, if you're interested in structural simulation, Altair SimSolid is the product you want to go for. Now, this is for more kind of stepping up from, I suppose, traditional FEA software to the next level. Now, the reason why I want to talk about SimSolid today is simply because SimSolid is actually it's a very kind of I would say non-traditional FEA software. The way it basically handles your issues, right, with the meshing, part gaps and overlaps, geometric complexity, smaller geometry features, any small splinter surfaces that you might have, is actually phenomenal. Now, I will be showing you a comparison between Inventor Nastran and SimSolid further down the webinar. It's basically a quick comparison of how both the softwares import a similar assembly, how you can work with both of those softwares on it, and the difference on why SimSolid is the next level. So I'm just going to quickly talk about what SimSolid can handle. So any model complexity, any parts that are 3D printed, additive manufacturing, lattice structures, organic structures, so anything of that sort generally becomes an issue within traditional FEA software. The reason is because your meshes or your parts can be so complex when they're to be additive manufactured, or 3D printed even, or using lattice structures. If you have used the element of generative design, it does tend to kind of lead to issues. The reason being, again, it doesn't handle complex geometry really well. Now, the next thing then is large scale models. So, another gripe with traditional FEA software is it can't really handle your large models. As you can see up there, we've got a little structure there. In traditional FEA software, this sort of assembly or this sort of example would be absolutely a nightmare for any engineer to bring into. Now, again, I'm not being a negative Nelly about this. I'm just being realistic. Essentially, right, any bolted connections that you would create within Inventor itself, for Inventor and Astran, you would have to take those bolted connections off and then go into the environment to actually define what sort of contacts they're going to be. So traditional FEA software don't really tend to do well with bolted connections or with wells as such. with SimSolid and traditional FEA software, here is a little comparison chart between the two. SimSolid reduces your workflow via simulation by a lot I suppose, by a lot, really. What it does is it doesn't involve any meshing. It doesn't use your traditional FEA techniques. And what ends up happening is you don't have to do any geometry cleanup. You can just design your assemblies, you can push it right into SimSolid, and you have results within minutes. Now, you also have automatic results convergence. So within traditional FEA software, you have to clean up your mesh. You have to make sure that your meshes are localized and you're not looking at any stress singularities or anything of that sort. So this tends to give you faster results. And again, I would advise trying to use it yourself before you believe my words around it, right? Now, the next slide that I'm actually going to show you is all about a comparison between the two workflows. Now, on the lower half of this window is your traditional FEA software, which is Inventor Nastran. Up on the or above this one is your Altair Sim Solid. Essentially, they're importing the same model within the software, and we're going to see what the workflow is like. So within Inventor Nastran, right, the video duration is actually 8 minutes and 20 seconds. This hasn't been sped up for either one of those videos. Essentially, SimSolid tends to import the model as a whole. It recognizes your bolted connections, so you don't have to get rid of any of that geometry that you've already created. So your geometry complexity can be brought in as well. It reads the files, evaluates the connections, and it gives you a summary or automatically assigns what contacts need to be made. Now here within Nastran, we're currently just assigning the material. Um, and we go through our normal steps of going from left to right within the Inventor Nastran menu to set up our model. So we're now going to go ahead and apply a constraint to this within Inventor Nastran. Within SimSolid, we're currently applying the material. It has already done the connections for us, and we're going to set up the structural linear analysis in SimSolid. Now at this stage, while we're applying constraints within Nastran, we're doing the exact same step in SimSolid. So you can see as a comparison, right? Both of them are actually going through the same phase where materials have been assigned, constraints have been applied, whereas in SimSolid, the connections have already been read. So we're just going to apply a load. So there is a gravitational load being applied in both of those models at this time. So SimSolid already has a constraint, has the load, and it's all ready to go. So we'll run the results, whereas we're just going to start detecting automatic contacts within our Nastran model. So SimSolid is currently calculating the results for us, while Nastran is trying to set up the automatic contacts. So I suppose just by looking at the video itself, again, like I said, they haven't been sped up or anything. This is actual. This is actually like a real life demo as such that we've recorded and we've put into the webinar. So it's something amazing to look at. To be very honest with you, simply because the results that we get are phenomenally fast. So you can see within SimSolid, we've already got our results, while in Nastran, we're still trying to detect the automatic contacts. So the difference, right, between both these products is absolutely huge. There is also a little bit in the Nastran software where it's going to go ahead and still detect automatic contacts. You can see it's currently setting up the mesh. So this is where I've actually had to speed up the video so that I can show you guys how long it generally takes. Within Nastran, we're still struggling to put the mesh along with it. The mesh has already failed once, so we're going to kind of retry and see if there's any improvements to be made. So Nastran is still generating the mesh, as you can see, and it's actually gone and crashed. So you can see the difference essentially. This is what I want to show you guys. So this model was provided to us by one of our customers, Ropton Handling Technology. So yeah, the idea behind showing you both of these softwares, right, side by side, is to show you the difference in the workflows and how you can actually simulate faster with Altair SimSolid. Now, again, if you need to go through a few bits, there are offerings that are available around product information, around the videos themselves. There's also blog posts that are available. We have also got the benchmark reports, or the NAFEMS report, or NAFEMS report, that is going to help you understand a bit better on why SimSolid is so much faster. And again, the accuracy of the results is exactly what you would get with traditional FEA software as well. We do have a couple of recorded webinars as well, and we do also offer a couple of training courses. So talk to us about your simulation requirements, and we'll advise you the best solution that you can currently use. Um, so again, I just want to reiterate our cornerstones. We're here to help you with leading edge technology. We have in-house expertise and knowledge to help you set up your workflows, help you on the digitalization journey, and be able to work smarter while having Symmetry as your trusted partner. So, just a future roadmap on what is planned. On what is planned within Ireland. So we do have trials available to download. So if you'd like to try SimSolid for yourself and test it out and see how the workflows work out for you, I would advise, or I would recommend, that you contact us and we can set you up with trials as well. We are also planning to conduct a series of workshops where we hope to see you guys bring in your own problems, and we can discuss how simulation can improve those and how SimSolid specifically can help you with those as well. We do offer consultancy services, so for companies who don't have the in-house expertise and do require a bit of help in getting up and running, we are obviously here to help. So please don't hesitate to contact us if you need any sort of consultancy services, or even if you have any training requirements. We're obviously happy to discuss further. So hopefully I'll see you in my inbox, and that is my email right there. So you can contact me at siddhant.jain@symmetry.ie. Um, and I would love to hear from you guys. And if you have any questions, I think that email there that you're looking at is supposed to be symmetry.com. So forgive me for that mistake, but I hope to see you in my inbox. And hopefully, if you have any questions, I'm here to answer them. Thank you for joining me today, guys. It was great seeing you on the webinar, and keep an eye out for our simulation offerings. It's going to grow rapidly in the next couple of months. So hopefully we'll chat soon, and thank you for attending um, today. Have a great day, guys, and I'm going to talk to you soon.